replenish naturally in a short period of time. They are sustainable and have a minimum impact on the environment. For example, solar energy. This energy is harnessed from the sun using solar panel. Solar energy is used to generate electricity and heat. For example, many homes use solar panels on their house to power their household appliances and lighting. Wind energy, for example, wind turbines convert the kinetic energy from the wind into the mechanical power, which can then be converted into electricity. For example, wind energy in use in the large wind farm found in the place like Texas, USA, which supply power to thousands of homes. And hydro energy. This energy is derived from the movement of water, typically in rivers or dams. Hydroelectric power plants use the flow of water to turn turbines. They generates the electricity. Geothermal energy. This is also type of renewable energy sources. This energy comes from the heat stored beneath the Earth's surface. It is used to generate electricity and provide heating. For example, geothermal plants in Iceland, which take advantage of the country volcanic activity to produce a significant portion of of its electricity. And second type of energy sources is non-renewable energy sources. We know that non-renewable energy sources are those that cannot be readily replaced by natural means at a pace quick enough to keep up with consumption. These sources are finite and can have significant environmental impacts. For example, coal, oil, natural gas, nuclear energy. These are the types of non-renewable energy sources. For example, we see first C, coal. Coal is a combustible black or brownish black sedimentary rock used as a fuel source for electricity generation. For example, the coal-fired power plant in China generate a significant portion of the country electricity, but also contribute to air pollution and greenhouse gas emission. Or next is, for example, oil. Oil or petroleum is a liquid fossil fuel used mainly for transportation, heating, and the production of plastics and other chemicals. The use of oil is evident in the vast network of cars, trucks, and airplanes. A well known example is the oil field in the Middle East, such as those in the Saudi Arabia, which supply a significant portion of the world's oil. And natural gas. This is a gaseous fossil fuel used for heating electricity generation and has an industrial feedstock. An example of natural gas used in the combined cycle natural gas power plant in the United States, which are more efficient and cleaner than coal fired plants. Nuclear energy. Nuclear power is generated through the process of nuclear fission, where the nucleus of an atom split into smaller parts, releasing a large amount of energy. For example, is the use of uranium in nuclear reactors to produce electricity, such as the plant in China, while the nuclear energy produces minimum greenhouse gases. It does not challenges related to radioactive waste disposal and risk of nuclear accidents. So these are energy sources, two types of energy sources: renewable energy sources and non-renewable energy sources. And then both types are also divided into more types. Okay, so next is environmental impacts of non-renewable energy. Okay, so what is non-renewable energy sources impact our environment? Air pollution. Non-renewable energy sources, particularly fossil fuels like coal, oil, and natural gas, are major contributors to air pollution. The combustion of this fuel The combustion of these fuels release pollutants such as sulfur dioxides, nitrogen oxides, carbon monoxides, and particulate matter into the atmosphere. For example, coal. Yes. Can you hear my voice clearly, everyone? And
Yes, ma'am.
okay. For example, we take an example and understand air pollution. Coal-fired plants are significant sources of sulfur dioxide, which contributes to the formation of acidic rain. This not only harms ecosystem but also buildings and movements. The burning of gasoline in vehicles releasing nitrogen oxides, which contribute to the formation of smoke and respiratory problem in humans. Second, it is water pollution. The extraction processes and burning of non-renewable energy sources can lead to water pollution. This includes the contamination of water bodies with chemicals, heavy metals, and oil spills. For example, oil spills such as the Deepwater Horizon spill in Gulf of Mexico in 2010 have devastating impact to marine and coastal ecosystems. The spill caused extensive damage to marine life, including fish, birds, and coral reefs, and several impacted the livelihood of people dependent on these waters for fishing and tourism. Please off the mic. Another example is contamination of water sources with chemicals used in hydraulic for natural gas, which can lead to unsafe drinking water supplies. And next is soil degradation. The extraction and use of non-renewable energy sources can lead to soil degradation through processes such as mining, drilling, and waste disposal. This gradation the land, making it less productive for agriculture and harming local ecosystems. For example, surface mining, particularly mountain top removal for coal extraction in the region of the United States, involves the removal of the large area of soil and rock to access coal seams. This not only destroy habitats but also lead to soil and the depositions of mining waste in nearby valleys and streams, contaminating the soil and water with toxic heavy metals and other pollutants. Similarly, the drilling for oil can lead the soil contamination from leaks and spills affecting agriculture productivity and ecosystem health. Okay, so what is greenhouse gas emissions? Carbon dioxide, methane impact on climate change when release the gases into the greenhouse. First is carbon dioxide. Carbon dioxide is a primarily greenhouse gas emitted through human activities, primarily from the burning of fossil fuels, oil, and natural gas for energy and transportation. And this, for example, the combustion of coal in power plant is a major source of carbon dioxide emission. For instance, the United States is one of the largest emitters of carbon dioxide due to the reliance the coal-fired power plant. These plants release millions of tons carbon dioxide annually, contributing significantly to the greenhouse effect, the global warming. And second is methane. Methane is the greenhouse gas with a much higher heat trapping ability per molecule than carbon dioxide. It is present in the smaller quantities in the atmosphere. Methane is released during the production and transport of coal, oil, and natural gas, as well as from livestock and other agricultural practice. For example, now we take an example and understand this process. Methane emission from natural gas production and transport are significant. The extraction process, including fracking and leaks from pipelines and storage facilities, contribute to methane emission. For instance, the 2015 in California released a massive amount of methane into the atmosphere, highlighting the environmental risk associated with natural gas infrastructure. Last is impact on climate change. Both carbon dioxide and methane contribute to the greenhouse gas effect, which lead to global warming and climate change. The increase in the gases enhances the natural greenhouse effect, trapping more heat in the Earth's atmosphere and causing global temperature to rise. For example, the rising concentrations of greenhouse gases are linked to various climate change impacts. This includes more frequent and severe weather events such as heat waves. For instance, the increased intensity and frequency of these in the alternating ocean have been attributed to the warming of ocean waters caused by higher levels of greenhouse gases. The melting of polar ice caps and glaciers due to rising temperature lead to sea level rise, treating coastal communities worldwide. Okay, health impact. What is the health impact? Respiratory issues, the combustion of fossil fuel release a variety of air pollutions, including particulate matter, sulfur dioxide, and nitrogen oxides. These pollutants can have significant effects on respiratory health. For example, in cities like Beijing, China, high levels of air pollution primarily from fire power plant and vehicle emissions have led to increased cases of respiratory issues such as asthma, obstructive disease, pollution air can these conditions leading to decreased lung functions and increased hospital admissions. And next is the cancer risk. Exposure to certain pollutants from non-renewable energy sources can increase the risk of developing cancers. Hazardous air pollutants such as benzene, formaldehyde, and polycyclic aromatic hydrocarbons uh, are known case to cancer risk. For example, um, a town is located near numerous petrochemical plants and refineries. Residents have reported higher than average rates of cancer, including lung, liver, and skin cancers, attributed exposure to toxic emissions from the nearby industry facilities. The presence of these hazardous chemicals in the air, water, and soil poses significant health risk to the core populations. And next is cardiovascular diseases. Air pollution from non-renewable energy sources also contributes to cardiovascular diseases. Pollution such as particulate matter and nitrogen oxides can enter the bloodstream, causing uh, and damage cardiovascular systems. For example, studies have shown that in areas with high level of air pollution, such as industrial regions with numerous coal plants, there is a higher incidence of heart attacks, strokes, and other cardiovascular diseases. For instance, residents living near coal plants in regions like the United States have been found to have higher rates of heart disease compared to the national average. So this is our parts impacts our health. Impact on biodiversity. Okay, habitat destruction. First, the extraction, processing, and transportation of non-renewable energy sources often result in habitat destruction. This destruction can directly eliminate habitats for various species, including plants and animals. For example, we take an example and understand habitat destruction. Mountain top removal mining for core involves clearing forests and removing the top of mountain to assess core seams. This process results in the destruction of entire ecosystem, including forest, streams, and wetlands, and eliminates habitats for wildlife species such as birds, mammals, and etc. In regions like United States, this form of mining has led to the loss of thousands of acres of biodiverse forests and fragmentation of habitats. And next is species extinction. Habitat destruction, pollutions, and climate change caused by non-renewable energy sources can drive species by disrupting their habitats and ecosystems. Okay, for example, the Amazon rainforest, often referred as the ranks of the earth, is home to the vast array of the plant and animal species. Deforestation driven by activities such as logging, agriculture, and mining, including for oil and gas extraction. The survivor of countless species. Species like the Amazon river dolphin and the hornbill eagle risk of extinction due to the habitat loss and fragmentation caused by these activities. Last is ecosystem disruption. No renewable energy extraction and production can disturb entire ecosystem, leading to loss of biodiversity and ecological imbalance. For example, hydraulic fracturing for natural gas extraction involves injecting high pressure fluid into underground rock formation to release gas. This process can continue groundwater aquatic ecosystem and fragment habitat. In regions where fracking occurs, such as North United States, freshwater ecosystems are at risk due to the water pollution and habitat degradation impacting species such as fish and aquatic plants. Okay, and next is water use and pollution. Water consumption in energy production. Energy production, particularly from non-renewable energy sources such as fossil fuel and nuclear plant, often require significant amount of water for various processes including cooling and extraction and processing. For example, fire power plant, which generate a large portion of the world's electricity, require substantial amount of water for cooling purposes. Water is used to cool the steam they drive turbine to generate electricity. Okay, the USA, one of the largest coal fire power plant in the United States, consume millions of gallons of water daily from the nearby uh, any city. This high water consumption can strain local water resources, especially in regions prone to water scarcity. Contamination of water sources. The extraction, processing, and disposal of non-renewable energy sources can lead to community contamination of water sources through spills, leaks, and the release pollutants. For example, fracking, a method used to extract natural gases from shale formation, involves injecting a mixture of fracture the rock and release the gas. This process can contaminate groundwater and surface water sources, which chemical use in fracking fluids, as well as with naturally occurring pollutants such as heavy metals and radioactive materials. For for instance, residents reported in instances of methane contamination in their drinking water wells attributed to nearby fracking operation, leading to concern about water quality and public health. And next is waste generation. Energy production, particularly from non-renewable sources such as coal and oil, generates significant amount of solid waste throughout the life cycle of energy source, including extraction, processing, and combustion. For example, coal combustion produces large quantity of ash, slag, and other solid residues known as coal combustion residues or coal ash. These byproducts contain toxic substances such as heavy metals and pose risk to human health and the environment. For instance, Kingston fossil fuel coal ash spill in USA in 2008 released millions of cubic hauled of coal ash in the river, causing extensive environmental damage and promoting concern about water contamination and public health. Okay, nuclear energy production generates radioactive waste, primarily spent nuclear fuel and other radioactive byproducts, which require careful handling and disposal due to the hazards, natural and long term of president. One second. Okay. For example, spent nuclear fuel, the radioactive material remaining after nuclear fuel has been used in a reactor, poses significant challenges for disposal. Currently, most spent fuel is stored in on-site at nuclear power plant in temporary storage facilities. However, these storage methods are not intended for a long-term storage, and there are concerns about the safety and security of nuclear waste storage. For example, nuclear disaster in Japan in 2011, resulting in the release of radioactive material into the environment, highlighting the risk associated with nuclear waste energy management. The disposal of solid waste generated from the energy production poses numerous challenges, including finding suitable disposal sites, preventing contamination of soil and water, and ensuring long-term contamination of hazardous materials. For example, the Korean of coal ash disposal sites such as landfill and source impoundment, present significant challenges due to the potential for groundwater contamination and release of toxic substances into the environment. For instance, the ongoing cleanup of coal ash ponds power plants, such as Dan River Steam Station in North USA, involves complex engineering and environmental efforts to address groundwater contamination and prevent further environment harm. What is social impacts of energy production? Okay, energy production projects, particularly large-scale infrastructure development, can lead to the displacement of communities and disruption of livelihood, especially among people and populations. For example, the construction of hydroelectric dams often involves flooding large area of land, displacing communities living in affected areas. For instance, the Tree Dam in China, one of the largest hydroelectric projects in the world, displaced over a million people and submerged numerous towns and villages along the river. The force of communities can result in loss of land, cultural, and social, leading to social and economic hardship for affected populations. Energy production industries create opportunities, but they can also lead to labor exploitation, job, and economic inequality, particularly in regions dominated by energy extraction and production. For example, the coal mining industry has historically provided jobs and economic opportunities in regions like United States. However, the decline of the coal industry due to the factors such as automations and market shift has led to job losses and economic downturns in coal dependent communities. Workers in the coal industry often face health and safety risks, inadequate and limiting opportunities for upward mobility. For instance, the closure of coal mines in towns like any country, high um, rates and poverty, social and economic challenges in these communities. Communities and regions heavily on energy production industry can become economically dependent on these sectors, making them in energy markets and shift in government policies. For example, oil dependent economies such as those in the Middle East often experience economic volatility and due to the fluctuations in oil prices and market demand. For instance, the decline in oil prices in recent years has led to budget and economic downturns in countries like Saudi Arabia and which rely heavy on oil to fund government services and social programs. The economic dependence on oil can hinder effort and limit opportunities for sustainable development in the regions. Okay, waste generation. Sorry, one second. Energy access and inequality. Energy poverty refers to the lack of access to modern energy services, such as electricity and clean cooking facilities, which are essential for meeting basic human needs and for economic development. This lack of access, these opportunities affect population in low-income countries and areas. People living in energy often rely on inefficient and polluting sources of energy like kerosene lamps, and traditional biomass for cooking and heating, which can have effect on health, education, and overall well-being. For example, in Africa, approximately 600 million people lack access to electricity. Many households rely on biomass fuels such as wood, charcoal, and dung for cooking and heating, which lead in indoor air pollution and respiratory diseases. Lack of electricity also economic opportunities, limit access to education, and hinders healthcare services. Okay, we take a 5 minute only break and then we continue again. Okay, now we start again. Disparities in energy access refer to the unequal distribution of energy resources and infrastructure among different regions, communities, and socio-economic groups. These disparities can be impacted by factors such as geographic income levels, government policies, and technological advancement. For example, in many development countries, urban areas typically have better access to electricity and modern energy services compared to other areas. This urban divide is often by factors like inadequate infrastructure, limited investment, and geographical challenges. As a result, communities may resort to using expensive and inefficient energy sources. The cycle of poverty and management. The impact on development. The lack of access to affordable and sustainable energy services can hinder socio-economic development in multiple ways. Energy poverty and disparities in energy access can impede progress towards achieving key development goals such as poverty reductions, health improvement, education, gender equality, and environmental sustainability. Without adequate access to energy, communities struggle to power essential services, businesses operate at a disadvantage, and individuals face barriers, economic opportunities, and social. For example, inadequate access to electricity in areas can limit the operation of essential services like schools and healthcare facilities, impacted educational outcome and public health. Moreover, energy supply can hinder the growth of small businesses and agricultural productivity. Okay, the access of clean cooking facilities like contributes to environmental degradation and health issues, particularly among women and children. Okay, so next is the renewable energy benefit. Renewable energy sources such as solar, wind, hydroelectric, and biomass little to no greenhouse gas emission during electricity generation. By replacing fossil fuels, which are the major contributor to air and water pollution, renewable energy help mitigate environmental damage and improve public health. Reduce pollution from renewable energy sources can respiratory diseases, mitigate climate change impact, and protect ecosystem and biodiversity. For example, the adoption of solar panel uh, in urban areas can significantly reduce air pollution caused by the traditional sources of electricity generation such as coal fire power plants. For instance, cities have experienced air pollution problems due to the fossil fuels. By promoting solar energy deployment, cities and mitigate air pollution levels and improve the health and well-being of their residents. Renewable energy sources are derived from natural processes that are constant replenished, making them sustainable compared to finite fossil fuels. Unlike fossil fuels, which have required extraction, transportation, combustion, renewable energy technologies harness energy from sources like sunlight, wind, and water without depleting finite resources or causing significant environmental harm. The renewable energy promotes energy independence, reduce imported fuels, and foster long-term environmental sustainability. For example, hydropower is a sustainable energy source that harnesses the energy of flowing water to generate electricity. Hydroelectric dams such as the Three Dam in China or Howell Dam in the United States provide clean and sustainable energy without emitting gases emission. Some environmental concerns relate to habitat disruption and sedimentation. Hydropower remains a valuable renewable energy option for many countries seeking to reduce their carbon footprint. Renewable energy enhances energy security by the energy maximum, reducing reliance on volatile fossil fuel markets and mitigating geopolitical risk associated with energy import. Unlike fossil fuels, which are subject to price fluctuations and supply disruptions, renewable energy sources are abundant and widely distributed country greater control over their energy supply and reducing the external shocks. For example, Denmark is a prime example of a country that has renewable energy to enhance its energy security. Through investment in wind power, Denmark has significantly reduced its dependence on imported fossil fuels and has become a net exporter of electricity. By harnessing its abundant wind resources, Denmark has achieved high level of energy self-sufficiency while reducing its exposure to volatile global energy markets. Okay, what is challenges we face with renewable energy when we use? One of the main challenges with renewable energy sources such as solar and wind is their intermittent uh, intermittency, meaning they are not constant available at all times or in all locations. Solar power generation depend on sunlight, which varies with weather condition and time day, while wind power generation relies on wind speed, which can unpredictable. Intermittency can pose challenges for grid stability, requiring energy storage solutions or backup power sources to ensure constant electricity supply. For example, in region with a high solar penetration, such as California, the duck curve phenomena, the challenge to integrating solar power into the grid. During sunny days, solar generation peaks, leading to the sharp decrease in demand for conventional power sources. However, as the sun sets and electricity demand rises in the evening, grid operators must rapidly ramp up alternative sources of power to meet demand, leading to operational challenges and potential grid instability. And other challenges associated with renewable energy deployment is the high initial cost of infrastructure development and technology implementation. While the operational cost of renewable energy systems are generally lower than the fossil fuel based power plant, the upfront capital investment required for building renewable energy infrastructure can be substantial. High initial cost can act as a barrier to adoption, particularly for developing countries or small-scale project without access to sufficient financing. For example, offshore wind farms are a promising source of renewable energy with vast potential for generating clean electricity. However, the development of offshore wind projects involves significant upfront investment in site assessment, turbine manufacturing, installation and grid connection, infrastructure. For example, the construction of the Block Island wind farm, the first offshore wind farm in the United States, required an investment of over of 300 million. Large-scale deployment of renewable energy infrastructure such as solar farm, wind turbine, and hydropower dam can have land use and ecological impact, including habitat disruptions, biodiversity loss, and alteration of natural landscape. Land-intensive renewable energy projects may compete with agricultural land or natural habitat, leading to overland use and potential environment degradation. For example, the construction of large-scale solar farm in deserts, ecosystem, or agriculture area can result in habitat fragmentation and loss of biodiversity. Hydropower project, while providing renewable energy, can alter river ecosystem, fish migration patterns, and affect water quality and quantity downstream. Um, for example, the construction of the Three Gorges Dam in China resulted in the displacement of millions of people and significant environmental impact into river ecosystems. Okay, one second. Okay, now we see any case study and the comparison both coal and solar energy, and discuss what is impact of coal when we use into environment, and what is impact of solar energy when we use into the our environment. Okay, so first, coal energy mining and combustion release significant amount of greenhouse gases, particulate matter, sulfur dioxide, and other pollutants into the atmosphere, contributing to air and water pollution. Acid land and climate change. Coal mining operation can lead to habitat destruction, land subsidence, and water contamination, impacting ecosystem and biodiversity. Okay, solar energy generation has minimum environment impact compared to coal. Okay, while the production of solar panel involves energy intensive manufacturing processes and the use of certain toxic material such as cadmium and lead. Advancement in solar technology and recycling are reducing these environment concern. Solar power generation produce no greenhouse gas emission or air pollutants during operation and require minimum water use, making it a cleaner and more sustainable energy portion. For example, in India, the expansion of coal-fired power plant has contributed to several air pollution problems, particularly in cities like Delhi. Okay, Delhi leading to public health crisis and environmental degradation. The deployment of solar energy projects such as solar power project in Tamil Nadu, okay, has helped mitigate air pollution and reduce greenhouse gas emission, improving local air quality and public health outcomes. The coal industry traditionally provides employment opportunities and economic benefit to communities dependent on coal mining and power generation. The long-term economic uh, viability of coal is increased challenged by factors such as declining coal reserve, environmental regulation, and competition for cheaper renewable energy sources. Coal-dependent regions may face economic decline, jobs issues, and financial strain as the coal industry. Solar energy offers significant economic benefit, including job creation, energy cost saving, and local economic deployment. The solar industry employs a diverse workforce in manufacturing, installation, maintenance, and research sectors, contributing to job growth and economic. Moreover, solar power can reduce energy costs for consumers, businesses, and government over the long term, enhancing economic and energy affordability. For example, in the United States, the coal mining industry has experienced a decline in recent years due to the market forces and environmental regulations, resulting in job issues and economic challenges for coal-dependent communities. States like California and Texas have seen rapid growth in solar industry, with solar energy becoming increased competitive terms of coal and job creation. For example, a solar power facility in California created thousands of construction jobs and continue to support local economical through operational and maintenance activities. Okay. Uh, the social impact of coal energy include health risk, community displacement, and social inequality. Coal mining and combustion activities can lead to respiratory diseases, um, cardiovascular problems, and health issues among workers and nearby communities exposed to air and water pollution. Moreover, coal mining operation may disrupt traditional livelihood, cultural and land-light communities, social tensions and inequalities. Solar energy promotes social equality, public health, and community by providing access to clean, affordable energy solutions. Solar project can enhance energy access in understand communities, improve health outcomes, and reduce energy poverty. Moreover, in community solar empower local residents to participate in renewable energy development, fostering social cohesion and economic self. Okay, for example, the widespread adoption of solar home system too, like the solar home system program has improved energy access for millions of households, reducing reliance and expensive and polluting energy sources like kerosene lamp. This solar system have had significant social impact, including improved health, education, livelihood, and opportunity for communities, particularly women and children. So next and last is technological innovations. Technological advancement in renewable energy have led to increased efficiency, lower cost, and expanded deployment of clean energy sources such as solar, wind, hydroelectric, and geothermal. These innovations encompass improvement in energy generation, conversion, and integration technologies, as well as innovation in materials, manufacturing processes, and system design. For example, solar cell represent a significant breakthrough in solar photovoltaic technology. These next generation solar cell use a class of material called um, uh, we say that perovskite, which have been shown light absorption properties and can be manufactured using low cost and scalable processes. Perovskite solar cell have the potential increase the efficiency and affordability of solar energy, paving the way for wider adoption and deployment of solar power worldwide. Energy storage technologies enable the efficient capture, storage, and utilization of renewable energy, addressing and variability of sources like solar and wind. Energy storage solution encompass a range of technologies, including batteries, pump, hydro storage, compressed air, energy storage, and thermal energy storage, which store excess energy during period of low demand and release it when needed to meet peak demand to stabilize the grid. For example, lithium-ion battery have emerged as a leading energy storage technology. And the electric vehicle industry and transforming the way electricity is stored and distributed. Advancement in battery chemistry, manufacturing techniques, and in economies of scale have led to significant cost reduction and performance improvement, making lithium-ion battery increase competitive for grid-scale energy storage application. Project like the Power Reserve in South Australia, which feature the world's largest lithium-ion battery system, demonstrate the potential of energy storage to enhance grid and support renewable energy integration. Smart grid, digital technology, sensor communication network, and advancement analytical and optimize the operation, monitoring and management of electricity grid. Smart grid enable time monitoring of energy consumption, grid condition, and renewable energy generation, allowing for dynamic adjustment to supply and demand, grid balancing, and energy efficiency improvement. The intelligent grid system facility the integration of renewable energy resources, demand response programs, and distributed energy resources while enhancing grid and ability. For example, the Enel Open Meter project in Italy is an example of smart grid deployment. The advanced metering infrastructure, communication technologies, and data analytic enable real-time monitoring and control of electricity consumption by providing consumers with detailed insight into their energy usage and demand side management practice. The smart grid initiative has helped reduce energy consumption, lower electricity bill, and optimize grid operations, contributing to sustainable and energy efficiency goals. Okay, so uh, the lecture is complete. Okay, so today our topic is environmental impacts when we use non-renewable energy sources and renewable energy sources. So actually this topic is very short because we only discuss the environment impacts due to the renewable energy sources and renewable sources. So no more time consume. Okay. So any question, anyone? Anyone asked me any question? Any question? Okay, so the session is end. Inshallah, we meet in the next Friday. Okay, love Hafiz.